Hi everyone, welcome to College Algebra. We are going to begin with a little bit of a refresher for solving linear equations and literal equations. Let's take a look. So notice here in your notes you have rules for solving linear equations. As a reminder, you have to use the opposite operation to move a term or part of a term to the opposite side of the equals. Remember that to keep the equation balanced, you have to move an entire term from one side to the other by either adding or subtracting. If you choose to multiply or divide, you have to do that to every term in the equation on both sides of the equation, every single term. And then finally, isolate the indicated variable. We recall that there are three types of linear equations: conditional, we have one solution; identity, we have an infinite number of solutions; and contradiction, there's no solution. Let's take a look at a set of problems where we can identify each of these types. We're going to start off by simplifying. So notice here we have 6x over 3. I can easily rewrite this as 2x. We have a plus 5. We're going to go ahead and bring this down. I like to work through problems from left to right, and I want you to get into the habit of doing that as well. Next, we see that we have a 4x take away 2x, so we're going to simplify those, combining them. And then plus, and then notice we have 15 divided by 3, which is 5. Because these are completely identical on either side, right? It maintained its identity. That means we can actually go ahead and say that the answer is infinite number of solutions. Now, sometimes this can be a little bit uncomfortable. So what you can do if you wanted to take this a step further to show a little bit more work is you can go ahead and subtract 2x. We're going to subtract the variable terms first. We'll subtract 2x from both sides. I want you to notice these are additive inverses, so they cancel out, leaving you with a 0. But 0 plus 5 is still 5. Same thing here, the 2x's cancel, leaving you with 0. 0 plus 5 is still 5. Notice that they are equivalent. 5 maintained its identity. So that's another indication that we have infinite number of solutions. All this means is if you take any number whatsoever and you plug it in for x, it will be an equivalent statement, meaning the left will be exactly identical to the right, which is actually pretty cool. Take a look at number 2. We're going to do, we are actually going to distribute to drop parentheses. So we're going to go ahead and distribute our coefficient of -3. So this becomes -6y and then plus 15. I'm going to go ahead and distribute my coefficient of 2. So that becomes -6y plus 14. Now, when you look at this particular equation, you may say, hey, hold on a second. How can -6y plus 15 be the same as -6y plus 14? Well, noticing that, we can actually say, hold up, this is actually a contradiction, which means my answer is no solution, right? It doesn't make sense. Now, again, sometimes it's helpful to actually take this a step further so that we could feel a little bit more confident. So I'm going to go ahead and add 6y. What you do to one side, do to the other. Remember, we have to add or subtract terms to move them. Additive inverses cancel each other out, leaving you with a 0. So we have 15 on the left-hand side because 0 plus 15 is 15. Same thing here, 0 plus 14 is 14. And that's a crazy statement. 15 is not equal to 14. We can say no because this is a no statement. Our answer is no solution. Let's turn the page. For number 3, we're going to do a similar tactic as number 2. We are definitely going to make sure we distribute as we move through this problem. So first things first, I'm going to rewrite 7p plus 5 is equal to, now let's distribute. We get 2p minus 6 plus 11. I'm going to clean up on this side. I have like terms, so I'm simply going to put them together, right? A -6 plus 11 is a positive 5. So we have 7p plus 5 is equal to 2p plus 5. Now, I'm going to focus on my variable terms first. So I like to move the smaller term over to the larger. So we have a positive 2p. We're going to go ahead and subtract 2p. In doing so, this is going to leave me with 5p plus 5 is equal to, and then again, notice those are additive inverses or opposites, so they cancel out, and then 0 plus 5 is simply 5. I'm going to rewrite this statement here because I simply do not have enough room. And let's continue. I want to solve for p, so that means I'm going to have to move the 5 over to the right-hand side to get it away from the term that I'm trying to isolate. I'm going to use the opposite operation, which is to subtract. That's going to leave me with 5p is equal to 5 take away 5 is simply 0. This time I didn't cancel it out, even though I can. I chose not to because I'm illustrating here that I actually have 0 as the numerical value on the right-hand side of my equation. You can't just leave it blank, right? That wouldn't make sense. Last step, I want to solve for p. I have to divide the 5 on both sides, and that gives us p is equal to 0. 0 is a valid solution, so don't be afraid of that. It would be different if you had a number divided by 0. A number divided by 0, that's going to be an undefined expression or solution, so the solution does not exist. So that's something to consider as well. But in this case, we have no problems. Let's take a look at the next problem. Okay. I want you to notice on the right-hand side, I've provided a strategy for you as a nice reminder. If necessary, distribute to drop the parentheses. And then if you have fractions in your equation, which we do in number 4, we're going to multiply every term by the LCD to clear those fractions. So I'm going to show you exactly how we can do this. It's really nice technique that you can use again and again and again. So the first thing I like to do, though, is to create some breathing room so that it's easier to see what's actually happening here. So all I'm doing is rewriting and creating some space in between each of my 4 terms. Now, I'm going to multiply every term by the LCD so that I can clear fractions. Notice on the left-hand side, my denominators are 5. On the right-hand side, my denominators are 3. However, I have to multiply every term by the same number. Like, for instance, I couldn't say, ooh, let's multiply this by 5 and then these by 3. No, it doesn't work that way. That would be breaking one of the rules, right? So we need to multiply every term by the common denominator. And in this case, if this side's 5 and this side's 3, well, 5 times 3 is 15. So we are going to multiply every term by 15. And this represents a 15 over a 1. If you'd like, you can write each 15 over a 1 so that it's easier to see that you have a numerator and a denominator, which is what allows us to reduce. So we can say 5 goes into itself once and into 15 3 times. I'm going to do that again. Let's move to the second term. 5 goes into itself once and into 15 3 times. Let's squeeze that in there. 3 goes into itself once and into 15 5 times. 3 goes into itself once and into 15 5 times. Kind of neat, right? So now look at what I'm left with. 3 times 8a plus 3 times 12 equals 5 times 4a plus 5 times 2. Let's do the math. 24a plus 36 is equal to 20a plus 10. At this point, I'm going to bring the 20a over to the left, and I'm also going to bring the 36 over to the right, simply because there's not a ton of room here, so I'm going to do these simultaneously. So let's go ahead and subtract the 20a term. Boom, gone. And now I'm going to bring the 36 over. Opposite operation every single time. So now let's write down what's left. 24a take away 20a is 4a. 10 take away 36 is negative 26. And then last step would be to divide by 4. Now, every time we have a fraction as a result, we need to see if we can simplify. The 26 and the 4, these are both even numbers, so they're definitely divisible by 2, but not divisible by 4. So let's simplify by dividing the negative 26 by 2, negative 13, dividing the 4 by 2, which is 2, and that is your final answer. Now, we are going to use the same exact strategy for number 5. For number 4, we had 4 terms, and we placed them in parentheses. For number 5, we still have 4 terms, so we're still going to be using parentheses. But we want to be careful how we do this. So the very first thing I would do is, again, rewrite this. Negative 3x plus 1 over 4 minus 2x plus 7 over 2. Notice I've left the negative in between, just like I did here. I left the positive here, I left the positive here. It's not inside the parentheses. I feel that when you actually separate it like this, it's easier to see what's actually happening, and you're less likely to lose the sign. Okay, so notice I've spread everything out. We're going to go ahead and use parentheses. By the way, as we move through these problems, if you're like, wait, I think I can actually try this, pause the video, try it out, see if you can actually move through this problem with the information we have so far, and then get the correct answer. Let's check it out. Go ahead and use parentheses to package each of your 4 terms. Your LCD in this case, notice is 4, 2, this is over a 1, this one's over a 1. Well, we can say our LCD is simply 4, right? If you said 8, that's fine. That's a common denominator. But 4 is going to work because they both can divide evenly into 4. So let's go ahead and multiply every term by the same quantity, 4. 4 goes into itself once. 2 goes into 4 twice. And there's nothing else that reduces because we do not have fractions. So here's where it's helpful to rewrite. So I know it's 1 times negative 3x plus 1, and you can just literally say that's just negative 3x plus 1. But for the sake of being consistent, I'm going to go ahead and rewrite it. You do not have to. So notice I now have minus 2 times 2x plus 7. So I'm going to physically write that out. If you accidentally skip this step and you say 4x plus 14, that means you're forgetting about this negative. So it's always helpful to rewrite because then you won't forget the sign. I promise you won't. 4 times a negative 11 is a negative 44. And then 4 times 5x is 20x. Now let's distribute to drop parentheses. I know we're just distributing a 1, so it stays negative 3x plus 1. But this time we're distributing a negative 2. So this would be negative 4x minus 14. That sign is super important. If you distributed the 2 and you didn't pay attention to that negative, this sign would be wrong and everything else goes awry. Okay, so we need to be very careful with that. Keep your work organized. On the left-hand side, I have terms that are alike. So I want to combine those first. A negative 3x and a negative 4x, that's a negative 7x. A positive 1 and a negative 14, that's a negative 13. So that's the first thing I'm going to do. I'm going to clean those terms up. And now I'm going to move terms from left to right. I'm going to take this negative 7x and bring it over to the 20x so that my variable term remains positive, which is nice. So let's add 7x to both sides. Perfect, that cancels. And at the same time, I'm going to bring the 44 over to the 13. So add the 44, add the 44. Perfect. Now let's see what we're left with. 44 take away 13 is a positive 31, and that's going to be equal to 27x. At this point, we'll divide both sides by 27, and then we'll take a look, are there any factors that go evenly into a 31 that also go into a 27? That answer is going to be no. So my final answer is simply x equals 31 over 27. I hope you got the correct answer. Let's turn the page. These next 2 problems are just a blast from the past. It's a quick reminder that if you are given a formula, you look for values that you are given and then you substitute them into the equation themselves. Here we have the simple interest formula where interest is equal to principal times rate times time. Remember, principal is like your initial investment. So we're asked to find the interest, right? How much interest? So that means our I is unknown. So I'm going to literally go through writing this equation and then substitute my variables as I move through. So it's, how much interest will be owed on a 5-year loan? So I know this is my time, but I'm not going to use 5 yet, of 25,000. Okay, there's my P. So I'm replacing P with 25,000. And then my rate is the 7.5%. So one thing I want you to be careful of is remember when you have a percentage, we're going to convert to decimal form before plugging into the equation. So 7.5% as a decimal is 0.075. Remember, you move the decimal 2 places to the left, 0.075. Let's go ahead and replace the rate with 0.075. And then we're going to replace our time, t, with 5. So at this point, we're going to go ahead and punch this into our calculators. After punching this in, we find that the interest owed on a 5-year loan of $25K at 7.5% simple interest is $9,375. And we're done. Similarly, with our distance formula, distance is equal to rate times time, rate being how fast, time being how long, distance being how far, right? So how long would it take? So that means we don't know the time. But we are told that the vehicle is traveling 113 miles. That's going to represent our distance at 45 miles per hour. So that's going to represent our time. So let's replace distance with 113. We're going to, did I say, I meant rate. Haha. So the 45 miles per hour is your rate. We're going to replace R with 45, and we're going to solve for T. If necessary, we're going to round to the nearest tenths. So let's check it out. I need to solve for T that's connected to 45 by multiplication, so let's divide. If you take that 113 and you divide it by 45, sure enough, I would have to round, and then this is going to be 2.5. And then remember, it's asking how long. Our rate is miles per hour, which means my time must be in hours. They need to connect, right? It needs to make sense. And that is our final answer. We're now ready to actually solve for a variable in a formula, aka solve literal equations. So some of the techniques that we have here are that it's helpful to actually read the problem out loud. If you can hear the actual operations being performed within the problem, then you know what the opposite operation is going to be. Additionally, you need to focus on how to isolate a particular variable in a sea of variables, right? And sometimes that can feel a little bit tricky. But with practice, I think you'll see it's not really much different than solving a linear equation as is with one variable, or even if it's the same variable on both sides, right? We have to focus on isolating the indicated variable. Let's take a look. I did give you some advice on the same page, page 4. Take a look at that. That's literally what I just described, but we'll go ahead and check out the problems now. All right, let's turn the page. Okay, for number 1, we need to solve for P. Here's my term with the P. I want that one by itself, so that means I'm going to get rid of Q. The opposite of minus Q is plus Q. We're going to add that to both sides. Notice I have B plus Q. I'm just going to read this from top down and then from left to right, just like I would read written English. So we have B plus Q is equal to 2 times P. I have one step left. I need to get P by itself, so I'm going to divide both sides by 2. So there's a couple ways to consider this. First, we could say that our answer is B plus Q all over 2. That's totally fine and acceptable, no big deal. However, it isn't uncommon to have to split these terms up. So instead of dividing both terms by 2 as like one fell swoop, we can actually divide each term by 2. So another representation for my answer would be b over 2 plus q over 2 is equal to p. And then lastly, the coefficient in front of this b right here is a 1. So technically this is 1b over 2 plus 1q over 2, which means our final representation can be 1/2 b plus 1/2 q is equal to p. So I want you to kind of play around with this and consider that these are all definitely equivalent. They're all the exact same equation. They're just written a little bit differently. And I want you to be able to do exactly that. Cool. Let's take a look at number 2. Notice here we have j is equal to k minus m divided by n. And I need to get m alone. M is in the numerator of this fraction, which means this fraction's got to go. So if we rewrite j is equal to k minus m over n, you probably are guessing I need to cancel fractions. So in order to do that, the opposite of divided by n is to multiply by n. What you do to one side, you do to the other. So notice the n's divide out on the right-hand side. So that leaves me with n times j, I don't need parentheses, is equal to k minus m. Cool. I need to solve for m. Now I could do this a couple ways. I can add m and then subtract nj. That would be totally fine. Or I can subtract k. This is typically the approach that many students take, which is why I want to showcase this. We have nj minus k. Write it exactly as you see it. Notice the k's will cancel because they're opposites, and you're left with negative m. Now here's the issue. We need to solve for m, not negative m. So at this point, we can divide every term by a negative 1, or we can multiply every term by a negative 1, or you can think about it as, well, if I were to multiply or divide by a negative 1, what actually happens? Oh, the sign of every single term flips, right? Because a negative divided by a negative is a positive. A positive divided by a negative is a negative. So the signs are simply going to switch. So let me show you what I would do. I would simply say, let's look at each of these 3 terms and flip, flip, flip. So my final answer is going to be negative nj plus k is equal to positive m. And again, that's the same as multiplying or dividing by that negative 1. Take a look at number 3. Number 3 is a great one. This is pretty tricky at first until you see it, and then you're like, okay, that's actually not that bad. First things first, notice r is in parentheses, which is fine. But that just means this 1/6 and that w gotta go, okay? We need to get rid of this coefficient so that we can drop the parentheses. As always, we know how to get rid of a fraction. We multiply by the LCD. So I'm going to multiply both sides by 6. Notice that's going to leave me with 6h is equal to, and then of course our 6's cancel. That 6 does not exist anymore. It's now a 1. So that means I have 1 times 1 times w, which is just w. You do not distribute the 6 inside. You already took care of it. That's why you physically cancel them out. They're gone. Now, you can distribute the w, but why? Why would you want to do that? Instead, let's eliminate the w. And we do so by dividing. This reads w times v minus r. So let's divide both sides by w. Notice here, they cancel. Isn't that beautiful? It's a beautiful thing. Every time you're dividing by itself, you are left with 1. So 1 times v minus r is simply v minus r. So I'm going to go ahead and rewrite this over here. 6h over w is equal to v minus r. Now, remember for this last problem, I said you could have added the m and then subtracted the nj. I want to showcase that for this problem, just to give a little variety here and teach you what you're allowed to do. I need to solve for r, but it's negative. So instead of having to worry about eventually flipping the signs, I'm going to take a different approach. I'm going to add r and bring that over. That means I have 6h over w plus r is equal to v. And then all I have to do now is subtract this term and bring it over. You might be thinking, well, wait a second, that's a fraction. Wouldn't you do the opposite operation? Remember, you can only move terms from one side to the other by either adding or subtracting, whichever is opposite. This is a positive 6h over w, so I'm going to subtract 6h over w. Now that I do that, I am left with r is equal to v minus 6h over w. And that is my final answer. Play around with this. Instead of adding the r and subtracting the 6h over w, why don't you subtract the v and then flip all your signs and see if you get the exact same answer. Remember, the order of the terms does not matter so long as your final answer has a positive r being equal to a positive v minus 6h over w, or a negative 6h over w plus v. All right, very nice. You probably can guess exactly what we're going to do for number 4. This is not as challenging as the previous problem. This one's a little bit more gentle. We're going to start with that fraction. Let's eliminate that denominator. We're going to do that by multiplying by 3. Multiply both sides by 3. That's going to give me 3f is equal to, notice these 3's cancel on the right-hand side. I'm just going to wipe those out. They divide out, leaving you with a 1. That means we're left with 2 pi j. And all I have to do is solve for j. J is connected to 2 and to pi by multiplication, so I divide. You are totally allowed to divide by more than one base, right? We have a 2 and a pi. We can divide by both because they're simply being multiplied together. So j is equal to 3f over 2 pi. And that's your final answer. And last problem of this block, which is very exciting, we want to solve for y, which means we're going to move this first term. Subtract mx from both sides. Boom, gone. We're left with by is equal to q minus mx. Exactly how we see it. Don't overthink it. And then finally, divide every term by b, or divide both sides by b, just like we learned a little bit ago. So my final answer is y is equal to q minus mx all over b, or y is equal to q over b minus mx over b. Either answer is totally acceptable. At this point, you're ready to check out solving linear and literal equations in your homework practice block. Take a look and see if you're able to tackle all those problems. Hope this helped. Bye.